Hi everyone, it's Sorkin. Welcome to my channel. Today we are gonna solve LeetCode 797, all paths from source to target problem. So let's first look at the problem statement. The problem statement is that we are given a directed asynclous graph of n nodes labeled from 0 to n minus 1. We need to find all possible paths from node 0 to node n minus 1 and return in any order. All possible paths from 0 to n minus 1. For example, in this case, and we are given two examples. In the first example, we have three nodes. So we need to find the way from first node to the last node. How many ways are there? As we can see, there are two ways. So as an input, we are given of the directions from, for example, for node 0, the directions are 1, 2. So from node 0, we are given 1, 2. It means that from node 0, we can go to 1 and 2. From the second node, we can go to 3. From the third node, from the 0 node, we can go to 1 and 2. From the second node, we can go to 3. From the first node, we can go to 3. From the second node, it's here, right? We can go to 3, and from 3 we cannot go anywhere. So the directions are, so there are two ways from that we can go from 0 to 3. And we are given another example. So for example, for the first one is 4, 1, 4, 3, 1, which means that from 0 we can go to 1, we can go to 4, and we can go to 1, we can go to 4, and we can go to 3, and other directions. And at the end, we need to return how many ways there are that we can go from 0 to 4. As you can see, we have 5 ways how we can go from 0 to 4. Okay, this is the problem statement. Let's see how we're going to solve this problem. Right, let's take our first example and let's a bit expand it and work on it. For example, 1 from 0. From 0 we can go to 1, and we can go to 2. We can go to 2, and from 2 we can go to 3. From 1, let's say we can go to 4. And from 3 we can go to 5, and from and the last element that we have, last node, is 6, and we need to find a path from 0 to n minus 1, which is 6 in our case, right? So how many ways to get there? How we are going to solve this problem? So it's a graph, so we're going to use one of the graph algorithms. The obvious one in this case is to use BFS, breadth first search algorithm. So we are going to use BFS algorithms. Let's just go over it step by step, how exactly it's going to work. So first thing that we are going to do, we are going to add to our, since we're using BFS, we are going to maintain a queue. We are going to add to the queue first element, which is 0, and then we are going to start from it. So we are adding 0, then 0, then we are breadth first searching. So first two elements is 1 and 2. So we are adding 1 and 2, and we are taking that from the queue. So then we are, since this is the first element, we are traversing this one, and we are adding, from 1 we can go to 4. So we can go to 4, and we took that from the queue. Another one is, then we are adding, so we are going to the next element, 2, then we are adding 3. We are taking this from the queue, and so on and so forth. So as we progress to 6, so we can see that from 4 and 5 we can go to 6, and we are collecting those values. The base case for us, whenever we are using the base case, whenever you are using BFS or DFS algorithm, or in general backtracking algorithm, we need to set the base case. The base case for us is when the last element is equals to the n-1, which means 6. That is the base case, and in that case we are going to add that to our result. That's it for this explanation part. Now let's go and put this explanation to code. All right, okay, let's solve. So first thing that we are gonna do, so since we are using breadth first search here, we are gonna create a queue of list of integers, and let's just call it a queue, and let's create a new linked list. Okay, so so since we're starting from zero we need to go to the n-1 element. So for that, for the queue, we are gonna add arrays as list. Let's add 0 here, so the first element. Then we are gonna also return the list of the list as result. Let's just create here, let's create it at the very beginning. So list of integers, let's call it list, and let's call it result, and new array list. Okay, so what we do here, and we need to return that, return result. So we create our queue, we create our result, we create our queue. Now we need to breadth first search our our graph, and visit all nodes, right? So we say here, while queue is empty, is not empty, is empty, which is not empty, then what we are gonna do? So first thing let's do is let's from our array, right, from our queue, let's just pull the from the queue, let's pull the current one, and whatever is right now, let's say that the 0 is there, right? So we pull the 0, and now we need to, before going to our graph, we need to add a base case. The base case in our case would be that if graph, then we need to, so basically if the current get, so if the current get current size, current size -1, so we are getting the last element in our current. Let's say that we pull that from our queue, we are getting the last element, and if that equals to the graph size, graph length -1, so the last element, then in that case we are adding the current, to the result add current. Okay, so we are taking the last element from there. So we pull the whatever is in our queue. We are taking the last element, and if that last element is equals to the let's say that we have 4 elements, right? Or so for each node we have its the other nodes that it's connected. So if we have, let's say that the 4 nodes, the last value should be 3, as in our case, right? So if that is equals to 3, that it means that okay, we have arrived to the last node, we can add that to the result. If not, then what we are gonna do, so now we are gonna iterate over our graph. So here we are gonna take the values, for example, for first case, right? For the 0, we need to get from the graph. We need to get from the graph values for 0. For how we can do that? The way we can do it, we can basically do the same. Current get current size -1. So we are iterating. So we are taking the first ones. So we have 0 node, which we took from the queue. First, we are checking that if it's the last node, it's not, then we are progressing further. And then we are taking the nodes that the 0 is connected to. So for example, in this case, we are taking those nodes, and what we need to do, we need to create a list. We need to create an array list. Let's just call it array of integers. Let's just call it temp result. Actually, it's not temp result, it's not temp results, and let's call it results then, and let's call this one result. Okay, so the new array list that we are adding, so the new array list, and we need to copy the previous one. Okay, previous list. We are adding to that list. To the current, to the result. We are adding to the result. We are adding our I, which means that element. And then what we do, we are adding our result, our I to the result, and then to our queue we are adding I. All right. And let me see what else we are missing here. Okay, let me check it. Yeah. Results, yes, result, we are adding current, yes. Yeah, we need to add result. All right, great. It works as expected. Let's go over it one more time. So what we do, again, we are using breadth-first search, and for that we are maintaining a queue. So we are creating a queue, and we are adding first element 0, the 0 node, and we are going over our graph. So the first thing is we are pulling from the queue, and we are checking that if the last element is equals to the if we have a base case last element, so that should be equal to the size of a graph minus 1. For example, 4 minus 1 should be equal to 3, and our last element here should be 3. So if it equals, then we are adding that to our results. If not, then we are going to our graph, and we are iterating over our graph. So we are taking the last element, and we are creating a list of the array list, and we are adding that to our list, and we are pushing it back to the queue. So the next time when we will receive, for example, let's say that the 0, right? We are at a 0, and we are creating a two lists for in here for the 1 and the 2, and we are pushing that to our queue. Next time when we will receive that here, we will receive 1 as a last element, and the next time, first we receive 1, then we receive 2, and then we are going in layer by layer, iterating our graph, and if that is matching our base case, then we are returning the result, adding that to our results, and returning our results. All right, hope it's clear. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.